This talk should be interesting. I found a few more things that I wanted to point out. To overview what's going on here, I found Walter Beatty, I'm not too sure how to pronounce that name, it's German. But he's the guy that invented the population 1, population 2 stars based off of his observations of the Andromeda galaxy in 1944 during, the World War II. And he had, was looking at the Andromeda galaxy because they had night raid drills where they had shut off all the lights. So there was very little light pollution, which allowed him to visualize Andromeda. But he said there was population 1, which are new stars, and population 2, which are old stars. High helium, hydrogen content with the old stars, high metal content, which is any element heavier than helium. And of course, population 3 stars, which are not observed. And stellar metamorphosis theory I'm drawing up has population 1. Now notice these are young as well, and they get older as they evolve. But population 1 stars are mostly plasmatic. They are in the visible spectrum. These are the young stars, which means every single star, according to establishment physics, is a population 1 star, according to stellar metamorphosis, because they all have visible spectrums. Now, when you get into the interesting part, stellar metamorphosis says the mostly gaseous stars do not have visible spectrums, but radiate in the infrared are population 2. Those are Jupiter, brown dwarfs, things like that. Population 3 are mostly solid and liquid stars. They have little to no infrared spectrum. This would be something like the Earth, or, let's see what else, maybe Mars. No, it needs a magnetic field, because if it doesn't have a magnetic field and it's solid material, mostly solid, then it's actually a dead star. That would be population 4. And then you have star guts at the very bottom, asteroids, comets, things like that. Now, I want to just go over this before I go into the next version of this talk, next portion of it. As we all know, the astronomers back in the 1940s, 50s, 60s, 70s, 80s, 90s, and currently today don't realize that a star evolves, and the chemicals that are synthesized in the galaxy are a direct result of stellar evolution. So we have two more differences as well. Inside of Big Bang, chemical evolution is dependent on galactic environment. How the galaxy synthesizes its chemicals and all the chemicals mix up depend solely on the environment of the galaxy itself. That is strange, because the galaxy is comprised of stars. So what they're saying is, literally, that how the galaxy evolves is a direct result of the ejecta material. Basically, you have your stars, okay? And they want to place chemical evolution outside of it, in this little area right here. Because to them, the majority of the elements that are created that are heavier than iron are from supernova. Now, those could be different phenomena. I'm not too sure exactly what they mean by supernova, because I have beef with the idea that a star gravitationally collapses once it synthesizes all of its iron. That doesn't make any sense, because they completely throw the Coulomb barrier under the rug, but more on that later. In other words, they want chemical evolution of a galaxy to be directly dependent on the space in between stars. That is the main philosophy. Okay? Now, with stellar metamorphosis, I'm just going to go SM. The chemical evolution of a galaxy is dependent on stellar evolution. Meaning, the stars that evolve are the objects that form the chemicals, okay? They're not the fusion reactors. They don't synthesize elements, okay? The galaxy itself already made the elements when it was born. It ejected it in huge jets of material. We see this in Hercules A and in large bipolar outflows in radio galaxies. Notice how none of this is mentioned in any mainstream publications. The fact that this material is undergoing fusion reactions as it ejects from the central regions of an active galaxy is completely glossed over. That is what's called galactic nucleosynthesis. It's a new concept that needs to be invented that just doesn't exist yet. But that's where the elements are made. But once the elements are out there, the synthesis of the actual chemicals themselves into, life, chemicals, rocks, and minerals is directly dependent on the star's evolutionary track. Meaning, the stars, which are formed after material is ejected from the active galaxy, are the places where the chemicals are synthesized. Meaning, chemical evolution happens right here, right here, right here, right here, right here, right here. And then when these objects smack into each other, okay, then that means they repopulate the galaxy with extra material, which then sometimes can enter into the stellar atmospheres, giving them distinct metallicity properties. In other words, they're forming an entire philosophy based off of just looking at the star and assuming its metallicity is directly dependent on some hypothetical Big Bang event, which is atrocious. What they should be doing is determining the actual, they should just look at the star. They should just look at it. If it's bright, it's probably really young and hot, And then the material that after it cools down and dies, it smacks into another older star, say a Mercury slamming into a Mars-type object, will then repopulate the interstellar environment with new metal after the star has recycled it. So basically, when they look at a star and they say, the metallicity, they're not really determining its age. They're just determining how much stuff it's sucked in from the interstellar environment. So metallicity, in other words, is not a good age determinant. Okay? But if you want to keep Big Bang, keep metallicity, and determine the star's age based off of how much metal it has. Fine with me. Keep that model if you want. But I don't think that the chemicals evolve in the vacuum. I think it takes actual stars to sort out all the chemicals and mix it up like a giant blender. But anyways, I think I made this video long enough. If anybody has any questions or comments, please leave them below.